This fifth quarterly film report of the National Aeronautics and Space Administration covers progress during July, August, and September 1960 on Project Saturn, under development at NASA's George C. Marshall Space Flight Center at Huntsville, Alabama. The Saturn system will be for general use in the heavy space vehicle field. With activation of the Marshall Center on July 1st, 1960, NASA assumed full control of Project Saturn as the Army relinquished program management. By the time of President Eisenhower's formal dedication of the center on September 8, 1960, NASA's historic effort to develop the gigantic Saturn space vehicle was well underway. Final assembly of the first Saturn flight booster, SA-1, at Marshall's Fabrication and Assembly Engineering Division, moved toward its scheduled completion this November. Earlier in the quarter, SA-1 assembly had been hampered by many engine modifications and by continuing shortages of miscellaneous mechanical components, such as pressure regulators, switches, hydraulic packages, and actuators. Assembly began last May, utilizing the same assembly station in which SAT, the first Saturn booster, used successfully for captive firing tests, had been accomplished. In other vehicle developments, a contract was signed July 28th with Douglas Aircraft Company for the S4 stage, second stage of the Saturn C-1 vehicle, the first flight configuration. Convair Astronautics is conducting studies for adaptation of Centaur-type hardware for use as the Saturn's third stage, called S5. Dummy upper stages are being made to be flown on the first few flight vehicles where only the booster will be powered. Modification and assembly of H-1 engines delivered by Rocketdyne was effected this quarter, readying them for installation on the SA-1. The booster unit is made up of a cluster of 8 such conventional liquid-fueled rocket engines, each developing 188,000 pounds of thrust, or an overall thrust of about 1,500,000 pounds. Installation of the first engine on the SA-1 began in August. Wraparound fuel and liquid oxygen suction lines were then attached to each engine. Through these lines, fuel and LOX are pumped from the respective tanks into the combustion chambers of the 8 engines. Electrical wiring and the pressurization system were also installed. 48 fiberglass spheres emplaced on the spider beam will store gaseous nitrogen at 3,000 pounds per square inch to pressurize the fuel tanks. By September, all 8 engines were emplaced for fitting purposes. Final installation of outboard engines and all suction lines was set for late September or early October. Installation of equipment in the SA-1's instrumentation canisters was also moving along steadily in the Marshall Center's shops. 4 canisters of the same general type will carry guidance, control, and telemetry equipment. One of these will house the ST-90 stabilized platform. Structural testing of SA-1 assemblies and components was typified by experiments carried out in the Structures and Mechanics Division on the 10,000-pound test tail section assembly, heaviest single structural part of the booster, to verify its structural design for flight loads and static firing rebound loads, and thus to determine if modifications may be needed. Testing includes gathering of strain gauge and photostress data, while loads placed on the tail section assembly in the test fixture simulate actual structural, propellant, and thrust loads. Ground support equipment, such as the support and hold-down arms of the Saturn launcher, also was undergoing rigid testing in a test fixture which can simulate loads the arms will be required to bear. The launcher at Cape Canaveral will have 4 retractable support arms and 4 hold-down arms. The support arms help to support the huge booster until after ignition, the thrust of the booster itself builds up sufficiently to enable it to stand alone. Then, the support arms must be moved back quickly in order to allow takeoff clearance for the booster's tail shroud section. The pneumatically operated arms can retract 62 inches in 84 100ths of a second. At full retract, the support arms send an electrical signal to the hold-down arms to release the booster. The hold-down arms can retain the booster until full thrust before release. Until called upon to hold down the booster, the hold-down arms also assist in supporting the huge vehicle. Eventually, all 8 arms will be sent by the contractor to Marshall for full simulation testing, individually and then as a complete system, before being installed on the launching pedestal at Cape Canaveral. As testing and assembly of SA-1 proceeded, the test booster, SA-T, emplaced in the captive test stand, was being modified and built up to conform to the SA-1 configuration. The modified version, called SA-T1, will be static tested in late November to prove out the flight configuration. These tests will enable the designer to incorporate any required changes in SA-1. Fabrication and structural assembly of the SA-2, the second flight booster, also was underway at Marshall, including circumferential welding of the booster's 8 70-inch diameter fuel containers, and work on the thrust frame barrel assembly, and the outriggers, thrust frames used to support the booster on the launching pad, and to which are attached the 4 outboard engines which gimbal for control and guidance. Beginning in September, a new assembly station for final assembly of the SA-2 booster was being installed. At Cape Canaveral, construction of the 65-acre Saturn launch complex is progressing satisfactorily. Major site items include a movable service structure 310 feet high, blockhouse, umbilical tower, concrete launch pad area, and high-pressure gas facilities. A beneficial occupancy inspection of the blockhouse was held July 7th, and Marshall's Launch Operations Directorate took beneficial occupancy on the same date. Work is also proceeding on the booster unloading facility. Construction of the Tennessee River facility at Redstone Arsenal, to be used for loading the Saturn booster onto its specially made barge, is scheduled for completion by mid-October. The booster will be loaded onto the barge from a dock at the end of a 200-foot-long slip cut into the bank of the Tennessee. The slip is 16 feet deep, 40 feet wide at the bottom, and 140 feet wide at the top. The barge in which the booster will be transported from Redstone to the Cape is due to be delivered by the contractor, Todd Shipyard of Houston, Texas, by December. Another big construction job got started at Marshall as the foundation was laid for the new Saturn Dynamic Test Facility, which will be used for vibration and other tests of the entire Saturn vehicle. The facility will feature a 204-foot-tall structural steel test tower, 27 feet taller than the present static firing test stand, with a stiff-leg derrick and hoist on top of it, and an adjacent control and instrumentation building. Begun in July, the Saturn Dynamic Test Facility will be ready for use by spring of 1961.